All right, hi. This is the AP Classroom Worked Assignment Solutions from April 7th, 2020. So you see the first one is up there already on the screen. It is a chart, and it says rocket A has a positive velocity v of t after being launched upward from an initial height of 0 feet at time t 0 seconds. The velocity of the rocket is recorded for selected values for the intervals 0 to 80 seconds as shown in the table above. Find the average acceleration of the rocket over time interval 0 to 80 seconds. So, the first thing I want to remind you is just if you have a distance equation, if x equals the distance, this will be on the next problem actually too, then the first derivative is the same thing as the velocity. We'll just keep going. It's the same thing as a velocity. What I would like to do is to f of x equals f of t, let's call that time, equals the distance. The function of distance is a function of time. And then if you have an equation that does that, and you take the first derivative of that, that's going to give you the velocity at any given moment time. And then if you take the second derivative of that, that's going to give you the acceleration. Notice, and this is a very derivative-y thing, right? I mean, it's kind of the point. The derivative of the distance is velocity, which is how fast the distance is changing. Rate of, I should put rate of change in distance. You can't even read that, but you know what I just said. And then acceleration is the rate of change of velocity, right? So let's keep that in your head forever. All right, so now what does it say? Find the average acceleration of rocket A over time 0 to 80 seconds. And we have the velocity. So we're actually already at this level, and it wants the acceleration, the average acceleration. So the acceleration of something is, and this really, I mean, it's sort of the understanding of calculus, taking differentials using this stuff, but this is not really even a calculus problem. So the acceleration of something is the change in velocity over the change in time. If you look at the chart, the change in time, we'll do that first. It goes from the last time is 49 minus the first time is 5. And, oh, excuse me, I just totally did that wrong. Yes, and I'm not going to just keep redoing this video over and over. Okay, so the change in time, it goes from the ending time is 80 and the beginning time is 0. And the ending velocity in feet per second is 49. I have to look around my document camera. And the beginning velocity is 5. I don't know how it starts at 5 feet per second, but it does. So that's going to be 44 over 80. And it was asking for, what is the average acceleration? So that's the average acceleration. And that would be in feet per second squared, because it's feet per second. And you can reduce that if you want to. What would it go down to? You could take that down to 11 over 20 if you want to. But again, I wouldn't if I were you. Just leave it like that, because that's right. All right, so that's one problem. Now the other one gets a little trickier. All right, so this is number 2 now on April 7th, 2020. And they give us this equation, which is this: x of t equals t minus 1 to the third times 2t minus 3. And they say that defines a particle's position along the x-axis. And what they want is to find t, find the value of t when the particle is moving. So when the velocity does not, does not equal 0, but the acceleration is 0, and a equals 0. All right, so, and we just went over that before about the derivatives, right? And you guys kind of know this, I think most of you by now. So if we have this is the distance, then this, the first derivative, is going to be equal the velocity, and the second derivative is going to equal the acceleration, because each derivative gives us the rate of change of the previous function, right? Velocity is the rate of change of the distance at any given point, and the acceleration is the rate of change of the velocity at any given point. So from here, we basically just have to do the derivatives. So let's get started. Hang on a second here. Let me get my notes. Where are all my notes? There we go. There's my notes. And then let's go back here and make sure that's showing what I want. Okay. So there's that. Okay. All right. So let's start over here. And we'll put x of t right here. And we're going to just rewrite it so we have it. T minus 1 to the third, 2t minus 3. And then what we need to do is do dt of this formula, right? So the first thing is we can break those up, right? Actually, no, we can't. That's the product rule right there. So we need to do the product rule. We need the product rule. And the product rule is the derivative of the first function times the second function plus the first function times the derivative of the second function. We should put little dots in there. So now we just do that, right? We're going to say our f is t minus 1 to the third, and our g is, so that's our f, and that's our g, f and g. And our g is going to be 2t minus 3. So then we got to get f prime. Oh, but look what f is. What's that? That's chain rule, right? So the derivative of the outside function, the outside function is this whole bit right there, right? And that's the inside function. So we're going to have to go 3, and that goes out front, right? So f prime, that's f, g, f prime is going to equal 3 t minus 1, and then we decrement that 1, right, times the derivative of the inside function. And what's the derivative of the inside function? Well, that's just 1, right? Oh, wait. Yeah, sorry, I get confused. So the derivative of the inside function is just t minus 1. The derivative of a variable would be whatever the coefficient is, and here it is just 1. So that's times 1, so we don't even have to worry about that. And then what's the derivative of g? If g is 2t minus 3, t to the first, that goes t to the 1, gets multiplied by there, that leaves 2, and t to the 0 is 1, that constant disappears, so g prime just equals 2, right? So now we can go back in and product rule this thing. We got our f prime, 3 t minus 1 squared times our g function, which is 2t minus 3 plus, and I'm going to run out of room here. I hope you can even read that. Might have to zoom in. Plus our f function, which is t minus 1 cubed. This is exactly what I tell you guys not to do. And that's 2. Oh, whew, good thing, huh? All right. So now we've got our whole thing there. And you could stop there if you didn't have to get the next derivative, but you do. So we'll say that's x prime of t, right? X prime of t. So let's see. Let's make a new place over here, and we'll rewrite that neatly so that we don't make more mistakes. X prime of t equals 3 t minus 1 squared times 2t minus 3 plus, I'm going to move that coefficient over on this side just because it's easier, it looks more normal to us, t minus 1 cubed. All right, so we can go a couple different ways. We can start like trying to chain rule all this stuff, or we can do, multiply these things all out. What do you want to do? Multiply them out or chain rule them? Let's just multiply them all out, I think. So I'm just going to assume, I'm not going to worry about that. I'm going to assume that. And then we're going to have 3. And this t minus 1 squared is going to be t squared minus 1t minus 1t minus 2t minus 1 times minus 1 is plus 1, right? And that whole thing has to be multiplied by 2t minus 3. Wow, that gets a little hairy too, doesn't it? So, plus 2. I'm starting to think I wish I would have just chain ruled this. I think I'm gonna. Because by the time we get to that whole deal, I think anytime it's bigger than squared, you're probably going to want to... That's just not going to be fun either way, is it? All right. So, let's see here. We can take the derivative of these two pieces separately. We can take the derivative of that separate from that. So let's call that F and G. So we're going to work on F right now. Let's push this down over here. Times 2t minus 3. So now we need to get the derivative of this. And of course we see the product rule and we see the chain rule. So let's see. So let's make this J and this one K. So J is going to be 3t minus 1 squared, and K is going to be 2t minus 3. Let's just do let's do the derivative of K right now because it's easy. It's just 2. And then we got to do J prime, which is going to be the chain rule, right? So we got to take that. So that's going to be 6, and then that goes down to 1, and then the inner function times the derivative of the inner function, which just happens to be 1. So that actually works out okay. That's not too bad, is it? So now we have to product rule this, which is going to be, it's going to be what? We're going to call it J prime times K plus J times K prime, right? And we have those. So we got J prime is going to be 6t minus 1. And K is going to be 2t minus 3 plus our J, which is 3t minus 1 squared, times our K prime, which is just 2. And now we just have to do more stuff. We can't forget about G. We've still got that up there, but we're still trying to deal with our F part, right? So let's see. Let's get this all straightened out here. So we can multiply that through, and we'll call that 6t minus 6 times 2t minus 3 plus 2 times 3 is 6t minus 1 squared. All right. And now we got to do 2. We got to FOIL this all out, right? So 2 times 6, that's going to be 12t squared. Outer, well, I'll just follow the FOIL. Sometimes I do the inner first, doesn't matter. Minus 3 times 6 is minus 18t. And then inner, minus 2 times 6 is minus 12t. And then last, minus 3, negative 3 times negative 6 is positive 18. And then we have plus, and we got to do this bit here. So that's going to be, we got to make sure we keep everything straight, 6 times, and then we're going to FOIL that out. That's going to be t squared minus 2t plus 1, right? So this whole bit is going to be 6t squared minus 12t plus 6. If I did that right, I'm just going to rewrite this for the sake of neatness. And there we go. So that gives us, we got a 12t squared and a 6t squared, gives us an 18t squared. And we'll get rid of those. And then we got a negative 18t and a negative 12t. That gives us a negative 30t. And then another negative 12t. That's going to give us a negative 42t. I'm not sure this is going to turn out. I'm not sure I'm doing this right. We're going to have to see. 12, 18, 30, 42. Did I? Yeah, okay, that's right. Okay. Get rid of those t terms. And then 8 and 6, that's plus 24. Now we have our g term over there to deal with. So that's our that was our f, and now we got our g, which is simpler, right? That's just going to be product rule. So g prime is going to equal the outer and the with the inner, and then so that's 3 times 2. That's going to be 6 t minus 1 squared times the derivative of the inner, which is just 1. So we can get rid of that. So g prime is going to equal 6, and then we got to FOIL that out, right? So that's going to be t squared minus 2t plus 1. And then we got to distribute that 6, so g prime is going to equal 6t squared minus 2 times 6 is 12t plus 6. So that's our g prime. And we have our f and our g. So now we got to go plus and put our g prime numbers in here and do one more combine like terms. And then we have done all our deriving anyways. Okay, 18, so that's going to be 24t squared. 18 plus 6, get rid of those. There's a negative 42t minus 12t is minus 54t, and then plus 30 is our final second derivative of t. I wonder if I got that right. I hope so. I did get it right. Good. That way I don't have to redo this. All right. So now we have, so this is our acceleration equation, right? And where'd our velocity equation go? That's our velocity equation right there. That's the same equation from over there, right? So that's v. So what we need to find out now is when our acceleration equals 0. So we have to find out when x of t equals 0. So that we need to set that equal to 0, 24 t squared minus 54 t plus 30. That is looking pretty quadratic, is it not? You remember the quadratic, right? That's the a term, that's the b term, that's the c term. And what is the quadratic equation? The quadratic equation, it's t for here, in this instance, right? And it is b plus or minus the square root of b squared minus 4ac over 2a. I think I did that right. So now we got to solve that. And our was that b or negative b? Crud. I'm just gonna tell you that I'm looking up because I already passed my teaching test. I don't have to pass it again. Let's see. That's a quadratic equation. Where's the quadratic formula? Is what I wanted. And I have to be able to type correctly. Formula. Okay, there we go. See, it isn't. I'm sure a lot of you were like going, it's negative b, it's negative b. There we go. And that's one of the things I would make sure I knew very well if I was doing it. All right, so back to this. Let's see. Okay, so we got negative our b is negative 54, right? That's our b. So that's going to be 54 plus or minus the square root of 54 squared. We don't have to worry about the negative because when you square something, the negative disappears. 4 times a, which is 24, times c, which is 30, all over 2 times a. And now I just have, let me, where am I? There I am. See, I just got my basic calculator here, square root functions and stuff like that. That's all you get. That should be all you need. So now we have, let's find this term under there. So that is going to be 54 squared, which is 2916, and that's going to be minus 4 times 24 times 30, and that's going to equal 2880. 2880. So under that is, so now we'll find the square root of that. So then we got 2916 minus 2880 equals 36. What? Square root of 36? You're telling me that equals 6? That whole radical thing equals 6? I guess that's what they're telling me. So 54 plus or minus 6 over 48. So that's either going to be 54 plus 6, 60 over 48, or 54 minus 6, which is going to be 48 over 48. So that equals 1, obviously. And why do I feel like I'm doing this one wrong? I feel like I've lost the plot here for a moment. And if I have, I hope that you have found where I've lost the plot already. Oops, that wasn't what I needed. 60 divided by 48. That's 1 1/4 equals 1.25. I did. Where did I lose it? Where did I lose the plot? I'm going to check the answer, and you're going to see that I lost the plot here somewhere. Oh no, I didn't. Look at that. How about that? Good for me. So that's 5/4. They're leaving that as 5/4, which is fine. So these are our two places where what? These are the two places where acceleration equals 0, right? That's what we were looking for. But now we got to use the second equation, our velocity equation, because the other criteria, remember we have two criteria, right? Velocity has to not equal 0, and acceleration has to equal 0. So, how are we going to figure out where velocity doesn't equal 0? Well, probably the surest way is just to plug them in, right? So 1's going to be pretty easy. Okay, so I'm gonna normally I would put it down. Normally I would put it down here at the bottom. Oh, I did. Was I writing off camera there? I probably was. Okay. Anyway, so normally I would want to keep going down, but I ran out of room. So now I'm going to put our velocity equation up here, and that is going to be 3t minus 1 squared times 2t minus 3. Oh, jeez. Here I go. I'm squeezing. It's exactly what I tell you guys not to do. T minus 1 to the third. Okay. So now we can just eyeball this. One of our two times where the acceleration is 0 is 1. So let's put 1 into here. If we put 1 in there, 1 minus 1 is 0. So that whole thing disappears. And 1 minus 1 is 0 there. So at x prime of 1, velocity equals 0. So that's not an answer. This is not an answer. This is going to be a non-zero answer. So this is going to be, this is actually the answer right there. Not, oops, I'm off the paper. Sorry. 5/4 is the answer, but it's not 1, because at t equals 1, the velocity is 0. And we were looking for acceleration is 0, but velocity is non-zero. So there's the answer. And let's see here. I'm gonna pull up the scoring guide here, and in fact, you know what I'm gonna do? I am gonna make that bigger so you can see it, because I have the technology. There we go. All right, so there's the whole scoring guide. 1 point is for the derivative. 1 point is earned for solving that has at least 2 roots, which we did when we got to the quadratic, right? And 1 point is earned for the answer. So here it is. I don't know what with their software they repeat these things twice. Anyway, and then I get to click that and give you a number of points when I go in and score your thing. So there, the particle's not moving at t equals 1, so there's the answer right there. And that's it. And I don't even know how long that took. But it took a while. A little bit longer probably because I'm trying to explain it while I'm doing it. But still, it's good. See ya. Bye.